Hey everyone, I hope you all are safe and doing well. Thought I'd do something a little different today. Instead of just throwing the PDF completed notes up on the classroom, I'm going to go through the first couple of pages of our next section. I'm not going to do much other than that. I don't want to create like half hour or an hour video. I'll try to break it down into short, 10-minute, 8-minute videos, and if I had to do multiple videos for different questions, and that's what I'll do. So we're going to start here. This is lesson 4.3 in your notes, and there's a couple of more sections that you guys should have that I gave out before we left. And I know the complete course of notes is in the classroom under that folder, but I'm going to change up some of those based on what you have. Try to streamline them a little bit. But for now, we'll pick up where we left off. So this is a situation now where we're still dealing with the derivative and we're still using the limit, but we're going to leave the x in. So like on your skill check you did yesterday and today, you put in a value. Well, now we're not going to put in a value, we're going to leave the variable alone. So just a little quick review here. It says, so this is our formula, and if we put in 2, so the derivative at 2, which means this red line here, right, has a slope of 4, and if we put in -1, right, that means this value here, so right here, this green line has a slope of -2. So we've talked about that. We've done examples, and that's what you guys did on your skill check. What we want to be able to do is get the slope anywhere. So right now, we got 2 and -1. Well, what about if I want a 10 or 100 or 20? So I need a formula that I can just plug in the x value and get the slope quickly. So if we look at the next page in the first example, so instead of using a equals a number, we just say a equals x, and we leave it alone. So the algebra here gets tricky because we're dealing with, variables rather than numbers, and therefore we got to keep our variables in place. So if we were to set up this one, x squared, one of the simplest derivatives that we can do, especially when we know the power rule down the road. So if we look at how this works, so the derivative will be the limit as h approaches 0. And what we need is f of x plus h minus f of x over h. So like before, we can get the x plus h and the f of x on the side. That's not what I like to do. So f of x plus h is really x plus h squared, and then that comes out to a binomial squared, which would give me x squared plus 2xh plus h squared, and then f of x is just x squared. So f of x equals x squared. So the goal is still to cancel everything out that doesn't have a h in it. So whether we use a number or leave x alone, that's still the plan. So we do limit as h approaches 0 of x squared plus 2xh plus h squared minus x squared all over h. And we can clearly see that the x squareds cancel out, which means we're left with limit as h approaches 0 of 2xh plus h squared all over h. Now we can see everything has a h in it, so we can factor out our h and cancel it. So h outside of 2x plus h all over h. They cancel out, and h approaches 0, so we can put in our 0 here for h, which means the derivative of x squared is 2x. So rather than having to do this every time, now we know that anywhere on the graph, So if we wanted to get the derivative of f of x and we wanted to put in 10, right? So the derivative of 10 would be 2 times 10, which is 20. So the slope of the tangent when x equals 10 for this quadratic is 20. And you can see some other examples on the side there. So that's a pretty straightforward example. Doesn't get too complicated algebraically. And now anytime you see x squared, you know the derivative is 2x. It's almost like a proof, because I'm going to give you rules later on where this can be done a lot quicker. But you will, most likely on your CPT at some point, have to answer a question using the limit definition. Alright, so let's look at one more, and then I'll leave it to you guys to work away on the practice. So this one here has x squared, but it also has x cubed. So that's where, you know, it gets a bit more challenging because we've got to do out a cubic. So I'm not going to show every single step. However, f of x plus h is going to give me x plus h cubed. And when you cube that out, you will get x cubed plus 2x squared h plus 3x h squared plus h cubed. Then we've got to do minus x squared, which we just did in the previous example, and that's going up on a slant there now. I gotta fix that. So x plus h squared, I should say. Just let me organize that a little bit better. Alright, so then this is going to be the cubed, and now we got to do the squared part, so minus x squared plus 2xh plus h squared. Well, that's really going up on an angle there. Okay, so that's our f of x plus h, which simplifies into x cubed. What else we got? Actually, nothing cancels out, so it's all just one big long string of unlike terms. So 2x squared h plus 3x h squared plus h cubed minus x squared minus 2xh minus h squared. Alright, so that's that one. Then the other one, f of x, is just x cubed minus x squared. So if you look at what's going on here, you can see that the x cubes and the x squares will cancel each other out when we set it up in our limit. So I'm going to move that down here. I'm not going to have enough space, so I'm going to move it right down below. So what that means is now I have to do the limit as h approaches 0, and I got to write all this out again. So that's, you know, that's the tedious part of it. If you understand the concept, you know what needs to be done next. So I'm just going to go through this fairly quickly to finish this one up. So that's your f of x plus h minus, that's your f of x all over h. So now our last couple of steps, the x cubed subtract x cubed cancels out. The negative x squared subtract negative x squared cancels out. And if you look inside, everything left has a h. So if we kind of kill two birds here with one stone, we'll take the h outside. What's left? We got 2x squared plus 3xh plus h squared minus 2x minus h all over h. So our h's cancel. Put in our zeros, and we get 2x squared, 3xh becomes 0, h squared becomes 0, minus 2x, and negative h becomes 0. And that's our answer. So just to state it, the derivative of f of x equals 2x squared minus 2x. We can factor that, but you don't have to. Factor out your 2x and you get x minus 1. So this function here will give me the slope of any tangent to the derivative of x cubed minus x squared. There you go, 10 minutes. So I didn't want to go any further today. I'll leave it there. Take a look at the examples. I'll put the PDF up with all the worked out examples. The CDLI video on this topic is pretty good, so you can take a look at that too. And we'll have an assessment when we get back after Easter on this topic, so similar to the one we did yesterday. Alright, take care, stay safe, enjoy your Easter break.